Okay, so today's notes are about compound interest. You should have already watched the introduction video that compares simple and compound interest, which was linked in Google Classroom. You can also type in this bit.ly link here if you haven't watched that yet. But you should have learned from that video that simple interest you only gain interest off your initial investment. So that initial amount of money you deposit, that's all that's going to draw interest. And that's going to look like a linear relationship. So you're going to get the same amount of interest every time they calculate it. The interest will be a percentage of that initial deposit. So it's a constant, like the same amount, it'll grow the same amount every month. A compound interest situation, though, is different. In a compounding interest situation, not only are you getting interest from your initial investment, but you're getting interest off of your interest, which is why this is an example of exponential growth, because your amount of interest is actually increasing each time because they're adding in your previously earned interest to that initial deposit value. So compounding interest accounts that gain compound or that draw compounding interest represent an exponential function. They grow exponentially, which means you get more money at a much faster rate. So the formula for calculating compounding interest, and if you guys need to pause the video to write any of this down, just go ahead and do that. But to try to make the video short, that's why I already have all this stuff typed up. So just pause anytime you need to write things down. The formula for compounding interest is right here at the bottom left. And we have some new variables that we did not have in our initial exponential function formula. So this formula is based on the original exponential function. P here is your initial value, and we're using a different variable because P represents your principal, and that's a money term for an initial investment. So this operates just like your A value did before. We're just using a different variable for this context. We still have, you can see 1 plus R, but now R is being divided by a value called N. So of course, R is still our interest rate. It's going to be written as a decimal, just like we have on any other problem that we've done so far this week. N, our new variable here, is actually the number of times that our interest is compounded per year. And different accounts can compound at different rates. And in a minute, we'll talk about the different amounts that you might see there. But it could happen once a year, twice a year, 4 times a year, 12 times a year. That value N is the number of times they compound your interest per year. And then finally, our exponent outside the parentheses, we do have a little multiplication problem happening here. We are going to multiply the number of times we compound by the amount of time that passes. So we're just going to plug all these values in anytime we are working with a compounding interest question. And then, of course, over here, f of n, I think yours says f of x, but f of n, same thing, is our total amount. So the value of the account after some amount of time has passed. All right, okay, so let's go here. Again, you can pause if you need some time to fill any of that in. I'm going to go ahead and go to the next slide where we're going to talk about some different amounts of time that we can have for our compounding interest. So it just depends on like the account you have or the bank that you're at or the type of investment you make, but these are some of the different amounts of time that we might compound. So this is going to be that N value. Oops. So N equals, it could be any of these numbers. So if we're compounding annually, that means one time per year. So N would equal 1. Biannually would be 2 times per year. So N would equal 2. Quarterly, you can probably guess, is going to be 4 times per year. So N would equal 4. Monthly would be 12 times per year. So N would equal 12. Now, semi-annually and biannually actually mean the exact same thing. So semi-annually also means twice per year. And so that will still be an N value of 2. And then finally, if we have an account that compounds weekly, that will be 52 times per year. And so our N value would be 52. I'm not sure how realistic weekly is, but we'll go ahead and write it down anyway. All right, let's take a look at our first example. We're going to determine here If we have an initial deposit of $4,000, we have an account paying 6% interest compounded quarterly. We want to know how much will be in the account after 5 years. So what I'm circling here are all the pieces of information that we need to know in order to solve this problem. And I'm going to go ahead over here. I'm going to write down all the things we need. We have a P variable, an R variable, an N variable, and a T variable. Those are all the little pieces we need. Okay. P stands for principal. That's our initial investment. And our initial investment here is $4,000. R is our rate. We know we write that rate as a decimal. This is 6%. Remember to turn it into a decimal. You're going to go left 2 spaces. So it is 0.06. All right, N, the amount of times we're compounding. Quarterly means, and you can go back to that table if you need to, 4 times per year. And then our time is 5 years. Make sure your time is in years. That's really important. Make sure I wrote that. Yes, time in years. It does have to be in years here because it has to relate to our compounding. Compounding interest is the number of times per year, so our time has to be in years, if that makes sense. Okay, we're going to take all of these values and we're going to plug them into our formula. So our total amount is going to be equal to our principal investment. Then we're going to have 1 plus, I'm going to plug everything in where it belongs before I worry about actually solving any of this. Right here, don't forget to multiply 4 times 5. Probably the most common mistake is that students forget that they need to multiply here on the outside for their exponent. All right, now the really nice thing is that we're going to use that calculator from yesterday. Remember, you need to have your equation written out because I'm going to be grading that. And then we're just going to type this entire thing in to the Desmos scientific calculator. So what I'm going to do is I'm going to actually switch over to a new slide or a new screen page here. And I'm going to go to desmos.com, if I can type, /scientific. And that's the calculator we used in class on Tuesday. Okay, so we have here the scientific calculator. I am going to type in exactly my formula, exactly how it looks here, and I'll show you how to do that. We're going to start with our 4,000, and then we're going to create a set of parentheses. Now, in the parentheses, we have 1 plus, and then I'm going to use the slash to make a fraction. So I'm hitting the slash button next to shift, and it's going to give me this fraction option. So I can put in 0.06 over 4. All right, then I'm going to close my parentheses, and then I'm going to finish with an exponent. So I'm going to hit this button right here, and my exponent is, I'm going to type in 20. It's 4 times 5. I think you could type in 4 times 5, but I'm going to go ahead and just hit 20 there. Okay. Now on the right side of my screen, you can see I have my answer here. We are talking about money. We are going to round to the hundreds place. So my answer is going to be 5387.42. So over here, I am just going to copy and paste that. There's my answer, 5387.42. And I'm going to put a dollar sign on that, of course. So that's the amount of money that would be in the account after 5 years. Okay, so let's think for a minute. If they started with $4,000 and now they have $5,387.42, how much free money did they get there? How much interest have they actually drawn? And you could figure that out. Sometimes the question will ask you just to calculate the amount of interest. So what you would do is you would subtract away that initial amount, and you'd be left with, after you subtract away your initial investment, this is all the free money, and I'm putting free in quotation marks because it's free in that this wasn't your money. This is just the interest that you've gained. So in 5 years, you get for free. You didn't do anything to earn this. You just stuck the money in an account, but you have $1,387.42 of free, in quotations, money. All right, let's look at the next example here. Again, we're going to find all these values and plug them into the formula. So we are going to deposit $6,500. Our account pays 8% interest. It's compounded monthly. I'll go ahead and circle all these little important pieces. Compounded monthly. How much will be in the account after 7 years? Pause the video and see if you can write down all of these 4 variables. All right, so hopefully you have a principal amount of $6,500. Your rate is 0.08, 8%, 0.08. N is 12. We're compounding 12 times per year. Monthly means 12. And then our time is 7. All right, now I want you to pause the video and see if you can fill all those values into the formula. Okay, here's what our formula is going to look like. We're going to have our principal. Inside our parentheses, we're going to have 1 plus 0.08 divided by 12. On the outside, this is important, make sure you have 12 times 7, which is 84. So our exponent on the outside there is 84. All right, I'm going to move over to my scientific calculator and type in my entire formula so I can get the value of this account, how much money will be in the account. All right, so I'm going to, oops. I don't know why that didn't work. Let's try again. There we go. All right, so I'll clear. We had $6,500. We have 1 plus, and then I'm going to use that slash to make a fraction. 0.08 divided by 12. It was 8% interest compounded monthly. And then I'll use this exponent button. And again, it was 84 for the exponent. So here's our answer over here. We are rounding to the hundreds place because we're dealing with money. And I'm just going to copy and paste that here into the slide. So the value of the account is going to be $11,358.24. That's the entire amount of the inside the account. Okay, the original and the interest that you've earned. All right, moving right along. I don't want to spend too much on each problem. Now, here's one that's different. This one says just calculate the interest. Now, there's not an interest formula, so we have to use the regular formula, and then we'll do that subtraction at the end. All right, see if you can come up with your P, R, N, and T and plug them into the formula. Go ahead and pause and do all of that. All right, we have something a little bit different here. We also have some new wording. Okay, this is not changing anything. This 8% per annum, it's not anything that's changing what's happening in our problem. So we still have an 8% interest rate. We have a principal of $6,000. You can see my numbers over here. Compounded annually. Annually means 1 time per year. So that's why N equals 1, and our time is 3 years. All right, so in your equation, which hopefully you already have written out here, you should have 6,000, 1 plus 0.08 divided by 1. And then here is going to be 1 times 3, which of course we know equals 3. So we'll plug that into our scientific calculator and see what we get as our, we're starting right now, we're calculating our total. Okay, so actually this is really easy for me to change here. I'm just going to change my denominator to a 1 and change my exponent to a 3. And that's, oh wait, what was the initial investment? $6,000. I do need to slightly change my initial investment there. All right, so here is our total. We are rounding money to the hundreds place. I'm going to insert that here. Throw a $sign on it. Now this value we've just calculated is our total account value. This is not the answer to this question. That's the total account value. We only want to calculate the amount of interest. So we're going to do an extra step here at the end. If we take our total and we subtract the initial amount that we invested, what's remaining is our interest. So we're going to get $1,558.27. This is the answer. That's the amount of interest that you've collected over those 3 years. That's your free money. I think we have 2 left. Charles and Linda want to have $1 million in 25 years' time. Okay, so this is not what they're depositing. This is what they want to have. This is what they want their end amount to be. We've got our time as 25 years. How much would they need to place in an investment account? That means, what is the principal? We are calculating the principal. We do not know the initial investment. Here's our annual rate, compounding monthly. Okay, so big difference. P is unknown. So we're going to actually leave P as a variable. Time is 25 years. We are compounding monthly, so N is 12. We have a rate of 0.095. And we actually know here, we already know the total. They want $1 million. So this is a very real world situation. This is kind of an example of people trying to figure out like their retirement. So like if I want to retire in 25 years and I need this much money, how much do I need to invest now? That's a real scenario. All right, so when I go to write my equation here, I'm actually going to write $1 million over here in the equal side because this is $1 million. P is unknown, so I'm just going to leave that as the variable P. And then I do have my rate. And out here, 12 times 25, oh, I think it's 300. 25. So 25 times 4 would be 100, and we have to do that 3 times. So yes, 300. All right. Now, what we're going to do here is we're going to use our calculator. We're just going to figure out what this equals. So we're going to type this part into our calculator. Let's go over to the calculator screen. I'm going to type that in and see what I get. So let me clear this out. I'm just going to do, and you do need the parentheses, 1 plus fraction 0.095 over, I want to say it was 12, but I'm going to go back and double check. And then our exponent of 300, exponent 300. All right, so I'm going to take all of these numbers. Okay, I'm going to take all of these numbers. I'm copying it. You might need to just write them down. All of those numbers are going to go in this little spot right here. P is multiplying. Our principal is multiplying by that number, and it's going to equal 1 million. So what we need to do now is we need to solve for P. We are trying to get P by itself. So we're going to divide by this entire decimal. And yes, I want you to put the whole decimal. Do not round anything until the end of the problem. So that cancels out, and we're going to get our principal by dividing here. So we're going to do 1 million divided by that decimal. Let's see. So let me copy this. Clear. 1 million divided by this decimal. Looks like we're going to get 93,888.41. So I'm going to put that number here. I rounded it to the hundredths place. Remember, we're not going to round till the end of the problem. Okay, so let's think about what this number means. Okay, this number is not the value of the account. This number is how much they should initially invest if they want to have $1 million in 25 years. That's their initial investment. Okay, so use the formula. This time we solve for a different variable. All right, our last question. Determine the value of an account after 4 years and 3 months if $47.50 is invested at a rate of 6.7% and were compounded monthly. All right. So let's see what we have here. We have a time. Now our time is 4 years and 3 months. That is not equal to 4.3. Remember, our time has to be years. So we have 4 years and then we have 3 out of 12 months, which would be 4.25. That's not going to happen a lot, but it could happen where you end up with a decimal in your time. So again, 4 years and 3 months is 4. That's your whole number. And then 3 out of 12 months, which is equivalent to 4.25. Our initial deposit, our principal is $4,750. Let's take a look at this rate here. Okay, remember to change our rate to a decimal, we're going to move left 2 spaces. So that's going to be 0.067. And our compounding is happening monthly. So that's going to be the number 12. All right. Now this question just wants the full amount. So we are just going to find our total here. Our principal is $4,750. We have 1 plus 0.067 divided by 12. And out here, we're going to have 12 times 4.25. So let's see, that's 48. I think it's 51, but you guys might want to check that, and I will check it. Actually, I'll go right here real quick. 12 times 4.25. 51. All right, just want to verify that. All right, I'm going to go over to my calculator, and I'm going to type all this in if I can remember it all. Clear this out. We've got 4750. We've got 1 plus. Our rate was 0.067. We are compounding monthly. Oops. And our exponent was 51. I'm going to double check that really quick. 0.067. Yes. All right. So here is our total account balance. Again, we are rounding to the hundreds place when we're dealing with money. I'm going to put that number right here. The question wanted the total, so I do want to keep this entire thing. I'm not going to subtract off the initial investment, and that is the total balance or the total value of the account after 4.25 years. All right, I think that's my last one. I know there are a couple problems still on these notes, so what I'm going to do is I'm going to pause the video for a minute. I'm going to go ahead and get the answers for those for you guys. You can work on those as well for the next couple minutes if you want to pause, and then come back to check your answers for those last. I'll probably just do like the next 3, 6, 7, and 8. All right, we've got example 6 here. The answer I got was $7,007.08. If you want to pause and look through my work there, you can see my initial equation. You can see what I calculated on the P side of the equation, and then I divided to get P by itself, the principal. Example 7, my answer is there is not enough money to attend a $10,000 college. When I plugged in the values, I got a total value of $6,204.84. Not enough money after those 18 years have passed. And then for example 8, it asked us to find the interest. Remember, we don't have an interest account or an interest formula, so we're just going to plug our values into the regular formula. I got a total value of 51,174 rupees. To get the interest, you just subtract the initial investment. So the interest earned is 21,173 rupees.